Alright guys, the purpose of this video is to give you some practice with relative dating and relatively dating rock layers. So before we get started with that, this is a pretty classic problem called a whodunit, and it talks about a crime being committed of someone taking the last cookie from the cookie jar last night, and it says that the last person to leave the scene is the one who took the cookie. So who is it? Pause the video, read the clues, and see what you think. All right, so let's take it clue by clue here. So it says the butler walks to work. The butler is the one with these dress shoes, and if he's the one that took the cookie, there should be no other prints or tracks or anything on top of his shoes, which there are, so we can eliminate him from speculation. The handyman rides a bicycle, and the bicycle is this skinny track right here. That's the bicycle tire, and you can see that there are tracks on top of his, so he did not take the last cookie. The cook rides a motorcycle. Motorcycle is this track right here. It has a track or print over top of it, so the cook did not take the cookie. The maid drives a car. You can see the two tire tracks right here. They have tracks on top of them, so she was not the last person to leave the scene of the crime. So that leaves the nephew with the seeing eye dog. There are his prints right here, and the dog tracks, they go with these black footprints, and you can see that these tracks have no other tracks on top of them, so he was the last person at the scene. Alright, so here are some actual problems. Reviewing the vocabulary that you had from your notes, uniformitarianism is the way that the rocks settle, and the way that they do that now is the way that they've always done. Superposition, rocks at the bottom layer are older than the ones on top. Horizontality is how the rocks get deposited from sediment. Originally, that's carried by water, wind, or ice, and the sediment gets laid down in horizontal or flat layers and then hardens into rock. And then cross-cutting, whatever is doing the cutting or covering up is younger than the layers that are beneath it because they had to be there in the first place. All right. You can read this through on your own. Pause the video anytime that you would like. This reviews some of the relative dating concepts from the video. Uniformitarianism, superposition, horizontality. That just means that sedimentary rocks are formed in a horizontal pattern. Before they're rocks, they're sediment, they're sand, they're silt, they're gravel that are carried by water, wind, ice, whatever is doing the transporting and depositing. So when they get put down horizontally, as you see in this picture here, horizontal, horizontal, horizontal. Then they could get folded or tilted or bent up in some way, but it's not until they are first put down horizontally. And then cross-cutting, you can see that this is youngest because it is covering up what is already there in the first place. All right, so this is the law of inclusions, and what it says is that if a body of rock, B, in the picture there, contains fragments of another rock body, A, it has to be younger than the fragments of rock that are contained in it. The intruding rock, A, had to have been there first to provide the fragments. All right, so here's a problem on the bottom here. I always do oldest to youngest. So there's 3 rock layers here, A, B, and C. Pause the video and put them in the order that you think they are from oldest to youngest. All right, so the oldest rock layer that was deposited or put down first would be C, because you have C here and C here. So the little bits of layer C that you find in A had to have been there first in order for A to cover them up. So A is the rock layer or the event that occurs in the middle, and then B, because of cross-cutting, cuts across or covers up both A and C. So A and C had to be there in order for B to cover them up or cut across. All right, so there's 3 problems here. We'll do them in order from top to bottom. So always oldest first. We're going to do number 6 here. Pause it and do these in order, and then I'll go through and do the answers, but I want you to try them on your own first. All right, so number 6, the oldest layer at the bottom would be layer E. I always like to cross these off as I go. Then we have D, then we have C, then we have F, and then B, and then A, in that order. Okay, cross section number 7, D would get deposited, and then C, and then B, and then A. And now the next layer or letter on here would be E, but in between A and E, this would get folded, okay, or bent. So these were all originally put down flat or horizontally, just like that. And then because of compression of the rock layers, they got folded or bent upwards, the way that you see in the picture here. So this happened before layer E was deposited or put down. All right, last one. Oldest would be C, then B, then A, and then D, the fault breaks everything. Okay, cuts across A, B, and C. So A, B, and C all had to be there first in order for D to cut across or cover them up. All right. So this is probably the toughest one on out of all 6 of these problems for number 10. So the order from oldest to youngest would go H, G, F, E, H, G, F, E. Okay, those were all put down horizontally or flat, and then they got folded or bent, so you see them at an angle here. Okay, so the next thing that happens or comes through is B, the unconformity. That erodes and it takes all this material away. D and C get deposited on top, and then A would cut across, and then J covers that up. Okay, so A is an extrusion because it makes it to the surface. Okay, and then J here is an intrusion because it stays inside the earth. All right, so number 11. Oldest would be E. Then we have D. And then we have C. And then we have A. And then B breaks them. And then F covers that up. So E was deposited, D was deposited, B was, or C, E, B, and C were all deposited, and then A cut across that, and then B broke it, and then F covered it up. All right, lastly, number 12. Oldest would be F, followed by E. Then you have G, the unconformity, and then C. Okay, and then you could go B, A, D. You have no way of knowing. So these three could go in a couple different orders. You could have BAD. You could have DBA. You could have BDA. Okay, really A just has to come after B. Okay, and that's kind of one of the limitations with relative dating is you don't know exactly what happened in this problem as far as the order, but you know the relative ages of the layers when you compare them with each other.